Hi, everyone. My name is David Monday. I work at Google, and I was asked to come today to talk to you about some of the data center server initiatives that we're working on. Just going to share my screen and we'll get started. Sorry, just one second. Okay, you should be seeing my slides now. So again, welcome everyone. My name is David Monday and I work at Google. Today we're going to be talking about server optionality for data center providers. I work on software within our technical infrastructure division inside of Google. We're responsible for all of the software that is deployed to our accelerator products and servers. So our servers include obviously x86 servers, and now looking at also ARM and alternative infrastructure as well, and thinking about how we keep our growingly heterogeneous data center commonized. We also write a lot of the software for the ASICs that we build at Google. We publicly disclose that we work on machine learning custom ASICs as well as video transcode ASICs as well. All of this hardware comes together into a server platform that needs to be standardized and controlled and managed, and of course tested. And so that's a lot of what we're going to be talking about today, is how we do that. So why am I here? Well, the first reason I'm here is because I want to ask the community to work with us. It's time for us to look at how we lift all the boats. And you're going to hear that theme again and again today in this discussion. But basically what we're looking at is saying, okay, there is custom hardware that we and our peers manufacture all the time, continuously. How much of that is common? How much of that investment across our industry are we replicating again and again? And how do we make that investment more efficient for all of us, but also for the ecosystem, so that as we build larger and larger systems and data centers, the rest of the ecosystem begins to flourish as well. We really feel that by building comprehensive, robust ecosystems, this is the way where both us as a hyperscaler and the community at large benefit by seeing the ripples in the pond of technology, so to speak. As we build something large, there's a lot of ramifications downstream in the supply chain and the qualification chain and the manufacturing chain. And we really like to start to see those investments grow. So the key question I come today with is, how many different ways do we need to build or verify a server functionality? Can we work together to do that? We think we can. So why are we even here though? So let's step back for a second. Data centers are growing increasingly heterogeneous. This is really a consequence of the end of Moore's law. Right, we talk about this quite often. At this point, Moore's law has slowed down or stopped altogether. And as a result of that, ourselves at Google and our peer companies and folks all around the world are starting to look at specialized hardware. So as I mentioned earlier, we work on custom machine learning chips, custom video transcode chips. We work on a host of different customized and very specialized hardware platforms to carry out some of the basic functionalities inside the data center that you'd expect: networking, storage, compute. In addition to that, we're always looking at alternative server technologies as well. Of course, we're never sitting still in terms of what we want for a performance advantage or a performance per TCO advantage. And as a result, that motivates us to look at alternative systems and technologies. Because we have that heterogeneity in our data center, it necessitates lots of different platforms. One server platform is not going to serve all of our services any longer, both for performance reasons, but also for cost reasons. Sometimes there are services that we provide that really don't need to be extreme high performance. We call those batch services. I'm sure many companies of similar scale have a similar setup where there are services that they sell that really just need to happen. But when they happen and how they happen, not really tremendously important. And spending a significant amount of our investment in those areas disallows us from spending it in some of the high priority differentiating areas that we want to focus on. And that really becomes the point of this discussion. We want to focus on where we can differentiate and innovate in the industry. And we want to lean on our peers and our supply chain, and our friends to help us build an ecosystem that enables us to do that. So the last point here is about complexity. Now, we've accepted that we're going to have a heterogeneous data center for the reasons I've outlined. But if that's really the case, where we're going to have ML specific systems, and we're going to have video transcode specific systems, and we're going to have storage systems and distributed compute and lots of new and emerging technologies in the data center, it means that as we walk through the racks, I wish I got to walk through the racks, but as someone walks through the racks, they're not going to see the same thing on every rack after rack after rack after rack. They're going to pass a cluster of one particular type of machine and a cluster of a different type of machine, and so on. And that's tricky because that person walking the floor is actually responsible for repairs. And usually those repairs are the most complex repairs that can be performed on these machines, because anything that's not complex hopefully has been automated away in the data center at scale. But those repairs stem from the original manufacturing flow when the machine was built. Ultimately, when we build a new machine, we have to define and deploy the repair flows and the diagnostic flows that are required for a machine, so that when the machine is in deployment in the fleet and something goes wrong, repair technicians are able to prescribe a particular set of practices on the machine and effect a correction. So now we get into, how do we define how we qualify these machines and standardize this? And so, as I said, complexity is a risk. It's risking our speed, that the speed of the person who needs to effect those repairs, or the speed of when we get a machine to market because we're waiting on manufacturing testing and diag flows, and also reliability. As we increase the complexity of these machines, we also have to acknowledge that the reliability of the machines could suffer if we're not extremely careful, because we're adding more surfaces that potentially can fail. So one way to mitigate risk that we all know is leveraging standards. So, we try very hard to work through the OCP and other standards bodies to ensure that we're deploying things that are as standard as is possible for our purposes. We do need to differentiate our technology, and often we have to build things. But as our senior VPs have said publicly in the past, we prefer to buy anything we can. We only really build things that we find that we can't find it the way we need it out in the industry. And so leveraging standards is extremely important into mitigating this risk and accelerating our ability to get products to market. So this also enables us to build core competencies in the ecosystem that we are a participant in. As we look for server vendors to participate in L10 manufacturing schemes, as we look for vendors who can provide us with ever increasing degrees of the server platforms that we're interested in, this means that those vendors are free to re-leverage that technology with other customers besides Google. And that's good for the industry, and it's good for us, because it ensures that the complexity and the reliability of these systems increases because they're seeing more action, more air miles. And also, we want to be able to break out generic work from data center operators, right? We want to aggregate that work with the vendors, as I said, because in addition to making sure that things get more air miles, it also ensures that talent pools at these vendors are stable and robust. One of the things that we've encountered as a challenge can be that when we work with vendors, oftentimes they may or may not have the talent at the vendor that's necessary to carry out the development that we really are seeking for the vendor to do. There's funny stories where we might work with a vendor and they might file a ticket to a GitHub because we're working on open source software and we want the community to benefit from what we're doing. But in the end, it ends up being a Googler who actually answers the ticket in the open source venue and solves the problem. And that's counter to what we're doing, because ultimately, if we're solving the problems for the vendors, then effectively we're doing the job. And the thing that we really want to focus on is ensuring that the community is doing this important work and that we're focused on the differentiating customized hardware that we need to build for our data center. The last point on there is also ultra important. Vendors move faster. Systems are usually more robust. This is true because vendors are incentivized to move fast. They need to move from each customer to the next customer. And so it's a different value chain for the vendor who's building a system than it is for, say, Google. Our value chain is about delivering services to our customers as fast as we can. But in terms of the platforms, our services are architected to be platform agnostic in the first place. And so the incentivization is different there. Another note I want to make before we get to the punchline here is a note on security. Security is important. What we mean by that specifically, though, is that it's not enough to simply say we can validate the functionality of a server any longer. The security attack surfaces, as well as mitigations, are equally important in the manufacturing stage of a server. We need to qualify and certify that a server is robust and reliable against common known vectors of attack and some lesser known vectors of attack. This stems all the way from supply chain security, all the way up to the management plan and data plane control security vectors. Some examples that I put there are OpenSSL. OpenSSL is a great example of an open software, security software that has had issues found in the past, but have been corrected very quickly by the community. And it's a great glowing example of why community engagement in these areas is really effective, because things move fast and quality is bolstered. An example of something that's worked a little less well is Dixie drivers within EDK2 or low-level boot software. What we found there is that we've actually had to ask for those Dixie drivers to be removed as much as possible in those lower-level boot softwares, because there's weak isolation between them, because they're being re-implemented in an environment that they weren't originally targeted for. This typically means that there are vulnerabilities that we find over time in those drivers that we can't tolerate in our servers. And so we have to ask for that to be removed. And that's really moved, at least us at Google, to Linux Boot, which we've been very public about. We rely on Linux Boot now, and Linux Boot relies on the community. And we feel safer in that regard because Linux Boot, again, is an open standard or open source project with a lot of community contributors that are looking at it and seeking for security vulnerabilities and also improving functionality regularly. So the big thing at the bottom there is that as communities react, all boats rise, as I said earlier. And this is true in security. It's also true in functionality and management. And so we want to be sure that we're building that community. So the other thing that we need beyond security is management itself. It's the thing everyone needs, but it should fade into the background. I say this again and again to my teams at Google. We really don't want to hear about management, except we do. I want to hear about management because I know it's always the Achilles heel that slows us down and potentially introduces bugs or gaps in our feature offering or in our repair flows. And so I need to know how our management story is doing. But in reality, it would be great if we didn't ever really have to hear about management. It needs to fade into the background. It should just work. It should mainly be the same stack from platform to platform. It should be platform agnostic. But each new platform that we're going to ship is ever more complex. It requires a new BMC image, sometimes a new BMC itself because of new I/O standards that we might need, or new capabilities in terms of performance. And then we need different health daemons and plugins and unique software. Like, oh, we have this new NIC. Now it needs different management. Oh, we switched NICs. Now it needs a different management. Oh, we want to do local storage. We want to do network storage. Those have different management stacks, and on and on. It's really important for us to standardize. We've been very vocal through the OCP and elsewhere that we want to standardize on Redfish, and we continue to work toward that goal. This is all to say that we're building up a story here at Narrative, which is my job here today, so excuse me while I play storyteller. But basically, security, management, community standardization, we want to build a community of server vendors and data center operators that are contributing tests and enable us to standardize on this stuff so that we're not hearing about management every server generation. We say, oh yeah, the vendors got it. They're using Redfish and they know how to manage this platform. We'll ingest the rules, the management rules from them. The same is true for security. Oh yeah. Supply chain security is good. They're following the protocols that we wrote up that are part of the larger community. These are not Google's only protocols. These are not this particular server's protocols. This is the community's feeling on how we do important topics like supply chain security and data corruption management and mitigation, things like that. So how do we want to do this? Well, Google has a software package called Open Vendor Software Stack. It's a bootable Linux image. It's a suite of diagnostics. And this is informed by 2 decades of data center operating experience by Google. And we aspire for this to be open and agnostic to the target platform. So we are in the process of actually getting OBSS onto a GitHub repo that folks can look at and comb through. We are working on a project called Hyperstack through the OCP. That's going to help to contribute and standardize a continuous integration environment for the BIOS, the RAS surfaces, the BMC, basically the system software for a server at large. We want to create a program that standardizes that and invites our peers, our colleagues, and the rest of the industry to collaborate. Our vision is that CPU vendors would then have qualification programs. ARM has started one called System Ready that would pre-qualify servers in the background. So effectively, CPU vendors that are building reference servers would pre-qualify those reference servers. And there would be a host of vendors that are there now who are able to pick up a reference server and build a custom server for a hyperscaler. But because the reference server was already validated with this suite and it was approved by the CPU vendor, now the server vendor is able to build their custom platform product and they can test it using this test suite. And if they surface a bug, they can either compare against the reference platform and say that they've reproduced it on the CPU and work with the CPU vendor to find a fix, or they can see that the CPU vendor's reference platform does not exhibit the bug and they know that they've got a bug with their product and they're able to work with the community to find a fix. This ultimately, hopefully, will drive more choice in terms of server platforms, and that's better for the community. More choice will create more competition and it will accelerate the community's velocity. So how do we want to do this? We'd like to organize an OBSS community around an open source repo. We want hyperscalers and others to contribute tests. So imagine repos of Python tests, things like reboot the machine 1,000 times, things like a power virus, things like rowhammer tests. Vendors can consider what diags are essential for the product they're building, select a subset of that suite and run those tests. We want CPU vendors to pre-qualify new CPU reference platforms, which they already do, but we're going to ask that they start to use these set of tests. These are the very same tests we use inside of Google for our repair flows. But we also expect that as this becomes open, it won't just be Google's tests, but hopefully everyone's tests, the community's tests. And we'll ask the community of CPU vendors to use the community's tests to pre-qualify these servers. And we're hoping that by doing this, we're going to increase the velocity of these design manufacturers. So this is my last slide. I'm going to stop here. And my open question to the forum is, how do we do this? Could this work for you? And how would we work together? Do folks have thoughts? I don't know, Christine, if we can open it up for questions.
There's none in the chat yet, but feel free to write any in the chat, anyone who's on here.
So I see one question from Yang. Any updates on BMC standards from OCP group? I'm not familiar with any particular updates. Is there a particular area that you're seeking? Are the tests organized and required by functional area? Do you have gaps identified? Yeah, so Tom, the tests are organized. So there are CPU tests, there are memory tests, there are storage tests. So basically, think about a server platform being characterized into the various functional areas that are there, and then we write tests for each of those. Admittedly, today, because for the longest time it's been an inside of Google activity, it's basically like a giant collection of Python and C++ tests. But as we open source that, part of that effort is really going to be to organize and collate that. Lenaro is actually helping with that effort, and so they'll be helping us to organize that open source repo and categorize the tests. In terms of gaps that are identified, we do have gaps that are identified that we know we need to do a better job on. CPU pre-qualification is definitely one of them. We find CPU bugs late in the cycle, and we also find that we don't test at scale fast enough. So those are the kinds of test areas that we want to think about how we can replicate at scale testing faster. Okay, what part does system ready play in booting OBSS? Great question, Francois. So the idea here is that we want, and we've been talking with ARM about it, we want system ready to actually require qualification with OBSS. So the idea would be that when we see that a server vendor is producing a product that has been already stamped server ready, that tells us that it's OBSS qualified. And that implies that it's going to work with our repair flows and that we've already pre-qualified it for the requirements that we see at Google. We're hoping to do similar things with other CPU vendors as well. Is Google working with the CNCF Tinkerbell group? I don't know about the Tinkerbell group. Yeah, I can't really comment because I don't really know about the Tinkerbell group. I can say that OpenBMC and Redfish both are things that we're very invested in. And so if it's something we should know about, I'd love to talk offline and learn more about it, or maybe I can Google around and find information. When can we see OBSS on GitHub? That's a great question. I'm hoping, we're really working hard with Lenaro to get that set up. I'm hoping that we can have that ready within the next quarter or quarter and a half, at least for folks to poke at and take a look at the various tests. Okay, are there any other questions? Otherwise, I think we can stop there. Okay, great. I think we're done, Christine.